Welcome everyone. In this video I'm going to show you how to read the data from your electronic digital caliper with the help of an Arduino and send it to a computer or send it to a larger screen or whatever. It is very useful because you can use these more or less precise and accurate devices to make, for example, a DRO, a digital readout. They are used for milling machines, for example. So you can read out the displacement of the X, Y, and Z directions very precisely and digitally, so you don't have to rely on your eyes regarding the reading of the scale. So instead of reading the scale, you have a digital screen that you have to read. So yeah, I will show you how to read the data by just using a few components, and then I will show you a code which I obtained from the internet. But yeah, so now I show you the main components, which is basically the caliper here. Yeah, this is like a plastic, very cheap caliper. Not the best on the market, but it's very cheap. And then usually all of these calipers have a small, like a door or a window on the top, or usually like here, where there is a small part of this printed circuit board with 4 terminals. And basically these terminals are like, if I go from the red towards the black, then the red is the power supply, and then we have the clock or SCL and the data SDA connections, and then the ground. What you have to do, or what you have to know about this kind of circuit, that it operates with a small battery like this. It's like 1.5 volts or something like that, which means that the voltage levels of the signal are also the same. So you have to do a trick, and to be able to distinguish the low and high levels with an Arduino, you have to shift the logical levels of this caliper from 1.5 volts to 5 volts, which is done with this circuit. So basically a transistor and a few resistors. What you do is you connect the clock and the data lines of the caliper to one side of the port, and you also connect the same power supply, so the 1.5 volts. So that is on this side, on the T terminals, because that's basically the TXI, that is like the input. And then on the other side you have the outputs, like TXO for the clock and the data lines, and you also connect the 5 volts. So what I did here on this whatever is this called, testing board, this blob here is the 5 volt, the grounds connected all together, so both these sides and the ground from the Arduino. And then here on the corner I just have the 3 volts connected together, and not 3, sorry, 1.5 volt all connected together. And then here is the power supply, so basically the 5 volt output of the Arduino board. So what I do here is I have an Arduino Nano here, so I have the ground and the 5 volts. So the 5 volt comes here, one wire goes to the level shifter, and one wire goes to this converter. So basically I transform the 5 voltage to 1.5 volts with the help of this small board. This is a very smart board, because if we see the back side of it, there are different terminals. So basically you can have like 6 different like predefined voltages, because these are like connected to different resistors here. So if you solder together these small connections here and break the connection here, which is by default is connected to the trimmer potentiometer on the other side of the board, then you can have these predefined voltages. But if you want to use the potentiometer, then you leave everything like here, and I did the same, and you just adjust your voltage with this potentiometer. So what I did is basically I use this voltage regulator to match the voltage for the caliper. So the output voltage is like roughly 1.5, 1.6 volts from this board. So that goes here, and one part goes to the level shifter, to the lower part of it. So that goes to the low level, and then also goes to the caliper to provide some power to it, of course. And I can demonstrate to you if it works. So I just simply connect the USB connection, and then here I can see that if I open, it works. So we have power supply, and if this would be connected to the computer, because now it's connected just to a mobile charger to provide 5 volts to the board and everything, so then I would receive the same distance as we can see here on the serial port. So this is how it works, but I want to dig deeper. So now what I will do is I disassemble this part, and I just show you the connections from a closer perspective, and I also show you how this device works. So now I just basically remove the screws, which can be found here. Originally there is a sticker here which states the capabilities of this device, but I removed that sticker, so these 4 screws are revealed now. So I just remove these 4 screws. So now you have to be very careful, because there is a small metal part here which is basically a spring, then that can like jump out as it did, so this, and I will show you how to assemble it again. But this metal part is very important. So we have this, it's quite rigid, but metal would be better. And then we have this is the one part of the grid, and now we have the circuit board here. You can see these parts, these are basically the capacitors, because how this works is that you have a grid of capacitors on both sides. So you have these, and let me remove this. So under this ruler or scale, you have another set of capacitors like this. I don't want to remove all the way around, because I don't want to destroy the sticker, but here it doesn't matter. So we have this, it looks like piano keys or whatever. So what you do, that you align and misalign these capacitors over these capacitors, which will change the charge, and that is read by the circuit, and that change in the charge is converted into change of distance. So this is how it works. And I guess if you have a better device, then these grids are more fine, so they are smaller, and therefore smaller displacements can be detected, like with a finer resolution. So you can see, so these two are like sliding over each other, and then as you like change these alignment, you change the charge of these capacitors, and you can have like a displacement. So now I put this back, and this as well. So now I remove the board just to reveal the connections. So the 3 screws are removed. You have to be careful with this thing here. This is basically the connection to the LCD screen, so you don't want to move this. And it looks like as a piece of foam. I don't really know how this works, but yeah, you should not move that. But here is the interesting part. So I showed you that foam that connects to these terminals here, I believe. This is basically the microchip of the circuit. And then here are the 4 connections. So once more, on this side, on the left hand side of the board, you have the 5 volt input, or sorry, 1.5 volt input. And then if we go towards the right direction, then this, the second terminal, which is the blue, is the clock, and then the data, and then the ground. So you just simply solder the wires to these 4 terminals, but they are really close to each other, so be careful not to cause any like short circuits. And that's all. You don't have to put the battery in. You will power the circuit by using the other circuits. So I put this back like this. So the 3 main screws are back. Now we have to put back the mechanical parts. So there are 2 things. One is that this part here, you see this plastic part, so that should be in this small hole. So you should align this. But yeah, you will see that if you put this just at the end of the caliper like this, then if the caliper is closed, then they will be perfectly aligned. But you put it together like this, and you can see that it works. But you also have this metal part. So basically you have to like squeeze it a little bit and put it here in this part. So what it will do, like this is acting as a spring, so it will push this wall, like let's call it ruler, against this body back here. So it will cause some resistance, and it will not have any like slack or unwanted motions. So but we basically just put it here. So it gives rigidity to this. And yeah, you have to be very careful, because then if you like compress this spring, it really wants to move. And you should not move the calipers until you haven't put this on it. So yeah. Okay. So the spring is in, and all I have to do is just to put this on. So this is the circuit board. And now just screw everything back. So it's back. Yeah, it moves smoothly. Let's check it with power supply. Ah, it turns on. And it still works. So it works fine. So now what I will do is I will show you a picture where I just draw all the circuits and the connections, so you can easily reproduce this kind of circuit. And maybe I will explain a bit more about this. But once you have these connections, then it's relatively easy to do anything with it. And then you can use this circuit for anything. If you have a machine, a milling machine, and then you just want to have a digital readout, then this is a very cheap solution. Because I think that this whole circuit here is maybe like $10 US or maybe 12, but it's very cheap. So let's jump to the drawing now. So here are the main components that we are using in this circuit. So I took a picture of the logical level shifter here and inserted here, and also the back side of the voltage regulator. And then I just drew the connections of the Arduino that we will use, which is basically the plus 5 volt output voltage, the ground, and the two pins, digital pins. And then here are the connections for the digital caliper, the plus 1.5 volts connection, the clock connection, the data connection, and the ground. So what we have to do is basically connect the two outputs of the level shifter to the Arduino. So let's say D4 goes to DXO here, and D5 goes to the DXO here. So this is basically what we do. And then we want to shift the levels of this caliper. So basically what we do is let's say that the clock goes here, and then the data goes here, and the ground is common for all. So wherever you just have the ground, I just draw like this, and here also. So you have to connect all the ground together, and here, and then we go here. So this is also like ground, but these are all connected together, and also this one as well. So we have the input here, that's the plus 5 volts, so that comes here. The EN is the enable lag, but we don't want to use it right now. So we use the input like this, and I will use the trimmer potentiometer, so you don't have to change these things at all, but you just solder the wire here. And then the V0 plus is basically the, or VO plus, sorry, this is the output for the low level voltage. So what we do basically is we connect it here to the LV, and also we have to connect the plus 5 volt to the HV here, because this is the voltage level at our high level. So this is like the plus 5 volts, and then this wire is the plus 1.5. So essentially this will like convert or shift the logical level from 1.5 volts to 5 volts, and then finally the Arduino will be able to distinguish between 0 and 1 level, or low and high level. And RX is not used, so you basically just do this, and also you use the VO here to connect here. So now I will just draw like this. So the VO plus is also have to be connected to the output of the voltage regulator. So if we start from the caliper, so then this goes to the voltage regulator, the 1.5 volts. Clock and data goes to the two TXI connections of this two-channel logical level shifter. The ground is just the ground, so that is common for all the four devices. So we follow the clock and data lines, and then the level is shifted, and then the TXO for both lines go to the D4, D5 or whatever pin you assign. And that's all. We are finished with the data to the Arduino, and then we have another ground here, one ground here, and one ground here. So we connect them together with the voltage regulator and the calipers ground. And then from the Arduino, the plus 5 volt goes to two terminals. One terminal is the input of the voltage regulator, and the other is the HV connection of the level shifter, and that's all. And from the voltage regulator, yeah, we have the ground, I already mentioned that, and the V0 plus goes to the low level of the level shifter, and also it goes to the caliper as well. So I might like so this is basically the circuit, and yeah, I know this is not approved by any electrical engineer, but this is how I just try to show you the most simple way how to connect everything. And now basically you just have to upload the program to the to your Arduino board, and you can start using this as you wish. And I will not show you any code in this video, but you should check the description. I will make a copy of the code to my paste bin, so there is like a backup of it, but I will also mention the website where I took all the information for this circuit. So check out that website, because maybe that gives more information than I gave you here. So I think this was all, and I hope it was helpful for you, and you will see this digital caliper in my other project, because if you remember previously I did a displacement sensor using a slide potentiometer, but that's of course not the best solution. So I will replace that solution with this one, and I just have to make some adjustments to this thing, and I will show you the progress with the other project where I will use that displacement sensor. So I hope it was useful, and I hope you learned something from this video, and thank you for watching, and see you in the next video now.